Lesson 29, negative exponents and 0 exponents. So this could be a little bit of note taking today. Some rules that we're going to cover, and you'll be all good. All right, so let's start off with negative exponents, our very first rule. The very first rule of definition of, if we need to define x to the negative nth power, okay, n being whatever our exponent is, goes like this. And of course, we're talking about real numbers, and x is a real number that is not 0, so we're not talking about 0, then 1 over x to the nth power equals x to the negative nth. And then I'll show you some examples of that. All right, so that's the definition. We just defined x to the negative nth power. It's basically the reciprocal. Okay? So here we go. Here's some examples for you to make this handy for you. 1 over 3/4, 3 to the 4th power equals 3 to the negative 4th power. 7 to the negative 2nd power equals 1 over 7 squared. 1 over 5 to the negative 8th power equals 5 to the 8th power. 6 to the negative 3rd power equals 1 over 6 to the 3rd power. With me so far? It's basically we need to put things in the right format. We don't want negative exponents. We want to make our exponents positive. How do we make our exponents positive? Well, we have to start doing things. Okay? So you need to understand how that works. So let's put that into practice. Everyone else, quietly go to Mrs. Penn's room, except for algebra. We got another 5 to 10 minutes. Okay, got that? So let's put this into practice. 3 to the negative 2nd power. What does this become to make my exponent positive? I say quietly, depart. 1 over 3 to the 2nd power. That equals 1 over 3 times 3, correct? Which equals 1/9.
If we write it like, should we do 1/9 or should
You should do 1/9. Okay? Here's another one. All right, my exponent's negative. I want to change this so my exponent is positive. What does this look like? 3 to the 3rd power. And 3 to the 3rd power equals 27. I just wrote my exponent positively, and then I solved it. Okay? That's what we want to do. We want to write our exponent positively. Okay? So far, so good?
Are they ever gonna? Are they ever going to want you to do negatively?
Occasionally, yes, but they'll tell you. Usually, it's going to be positive. My exponent is negative. Just 1/9. Very good. Make sense? Okay, I didn't change, I kept my negative 3 negative, that didn't change. My exponent changed because I moved it across the line. Okay, I wrote it in the denominator. When you move it across numerator or denominator, it becomes positive or negative depending on which way you go. Okie dokie? All right, so that brings us to the product rule for exponents. The product rule for exponents tells us as long as our numbers are real numbers and our coefficient does not equal 0, then x to the x to the m power times x to the n power equals x to the m plus n. You should already know this rule. Applying that rule, putting that rule in practice, x to the 4th power, m to the 2nd power, times x to the negative 2nd power, times m to the negative 5th power, equals, add like terms, x to the x to the 2nd power, m to the negative 3rd, right? Later on, we'll do something else with that, but for right now, we're good. Okay? Make sense? All we did was combine like terms. Using our product rule is when you're multiplying numbers with exponents, you are adding the exponents to get it. Okay? Because this is 4x's and this is negative 2x's. You take stuff away and you get it squared. Okay? So far so good? Now, occasionally you're going to end up with 0 exponents. 1 equals 4 squared over 4 squared. A non-zero number divided by itself equals 1, right? If you divided 4 squared by 4 squared, you get 1, because 4 squared is 16, and 16 divided by 16 is 1, right? All right. So, to do it, what we've been learning today, what that problem actually looks like is this. You're going to have to unplug it. You're going to have to unplug it. All right. What this problem actually looks like is 4 squared times 4 negative squared, because we want to get this up here. Okay? If we apply what we just learned at the beginning with negative exponents, we move this one to the numerator, we get 4 squared times 4 times negative squared. Okay, what does that leave us with? Well, that leaves us with 4 to the 0 power. And the rule, new rule, is as long as we're talking about real numbers and our exponents and our real number is not 0, then here's new rule, x to the 0 power equals 1. Write that rule down. So anytime you end up with that exponent of 0, the number is 1. So we can do that to do some pretty handy stuff. X squared times y to the 5th times y to the negative 2nd times x to the negative 2nd equals y to the 3rd, because 5 minus 3 is 3, or 5 minus 2 is 3, x to the 0 power, which equals y to the 3rd, because x to the 0 equals 1, as long as x wasn't 0 in the first place. If x was 0 in the first place, the answer is going to be 0, right? All right, see how we got down to that? Does that make sense? So let's do something hard. X to the 5th times y to the 0 power times z. Distribute this. P to the negative 3rd, z to 0 power minus 4, x to the negative 5th, z to the negative 1. Let's distribute all that baggage. But before we distribute that baggage, let's make our life a little bit simpler. X to the 5th z times p to the negative 3rd minus 4x to the negative 5th z to the negative 1. Because I can dump out this z goes away because that's 1. And this y goes away because that's 1. Right? I don't need them there anymore. They're there, but they're invisible, so I'm not going to write them down. Okay? So far, so good? Let's distribute. First, this part to here. When I distribute that part to there, I end up with this. X to the 5th, z, p to the negative 3rd. Right?
What about 2?
I'm not, that's a z.
Oh,
Sorry, I'm being sloppy. Okay? Does that make sense? So far? Then I'm going to distribute that same thing over here. Keep in mind what I got going on.
Is that a 2 or a z?
It's a z.
Oh, okay.
Excuse my sloppiness. All right? You with me? X to the 5th, x to the negative 5th. Uh-oh. No.
So it would just be-
It's just 1.
Just
So
one.
it would just.
Okay, keep that in mind. That's just 1, right? Because 5 minus 5 is 0, right? And x to the 0 power is 1, right? Z to the first power and z to the negative first power is
1.
0.
0.
1 minus 1 is 0, right? Z's gone. Z is 1. All I have left with is minus 4. So that 4 can't go away. 4 is still there, right? But my x's got rid of themselves because x to the 0 power is 1. And z got rid of itself because z to the negative first power and z to the first power is 1. And 4 times 1 times 1 is still going to be 4. Right? It's still going to be 4. Let's do, I got time for one more to help you see this. X to the negative second power times y to the negative second power. X squared, y squared, plus 4x to the 4th, y to the 2nd. Okay, a lot of junk there. A lot of junk there. But when I do the distributive property, I can see that I'm going to get my first off, when I distribute my x to the negative second right here to my first term in the parentheses, I can see what I'm going to end up with. That I'm going to end up with x to the 0, y to the 0, plus 4x squared, because 4 minus 2 is 2, plus 4x squared, y to the 0, right?
So the answer is just 4x squared.
So my answer, no, it's not.
Is it
Oh,
1
you gotta be
plus
careful.
4x squared?
Yes, it's 1 plus 4x squared.
Wait, why is that 1? Why is that not 2? Oh, wait, never mind. I see.
Because 1 times 1 is
Yeah,
1.
No, I get, yeah.
Okay, I can't ignore the fact that these are 1s. Okay, they didn't go off and disappear. They became a 1. 1 times 1 is 1. So this is actually 1. This is 4x squared times 1. Well, that doesn't change it, so it's still going to be 4x squared. So my answer is 1 plus 4x squared. Question, I see. Miranda, and then Tony.
But 1 negative 2 plus positive 2 be 0.
Yes.
So how
So
is
then
it?
multiply.
Y to the 0 power is 1.
Oh, okay.
Right?
But then when is it just the number 0? Like,
It doesn't become 0.
It doesn't become 0, it becomes 1.
oh, okay.
So in the problem that we did before, right here, these all became 1s. So,
Oh,
but
only-
negative 4 times 1 is still negative 4.
But only when the number is written down already, like y to the 0 power.
That's 1.
Then it's,
It's 1. It's still there. I could write it in.
oh.
It's still there, but x times 1 times x to the 5th times 1 times z is still x to the 5th times z. It doesn't change anything. It just renames it.
Oh.
It renames it itself. Okay? Tony, you had a question?
Can we leave the 0 instead of making it a 1, or do we have to make it
What do you mean leave the 0?
1? Like, can we just leave x 0, y 0 plus that? Or do we have to make it 1 plus?
You got it. It has to be 1 plus 4x to the second. Oh, it would be wrong.
Oh, okay.
Because these don't go away. They just become 1s. 1 times 1 is still 1, right?
Mm-hmm.
So they don't go away.